Here we go, method number 3 for solving polynomials, and again we're kind of mostly focusing on quadratic. So this one's new, you've probably never seen this in Algebra 1. The other methods come up at some point in Algebra 1, but this one you probably have, you may or may not have seen, but I know that for the most part we don't cover this. So completing the square is kind of a strange one. So I want to take a look at just some stuff and then we'll get to where we're trying to, the kind of the big idea once we're ready. Okay, so we're just going to factor a couple of expressions. X squared plus 8x plus 16 factors into x plus 4 times x plus 4. Okay? X squared plus 12x plus 36 factors into x plus 6 times x plus 6. Okay? X squared plus 2x plus 1 is x plus 1 times x plus 1. And x squared plus 20x plus 100 is x plus 10 times x plus 10. Okay? And so I picked these trinomials on purpose because in each case they factor into the same factor twice. And when that happens, we can write this in a squared form. Right? These are all what we call perfect squares because they use the same factor twice, okay, when we break it up. Right? So each of these problems can be written as something squared, and if that's true, we can then, for example, if this was set equal to like 10, we could use the square root method, right? We like the square root method. It's a nice, simple, easy method. And if I had a way of recognizing that this is true, and I can turn things into their squared form, right here, if this was equal to 10, I could be like, cool, square root, solve my problem. It's only like 1 or 2 more steps, so I don't have to go through a big, long process. Okay? So if you take a look at these numbers, again, these expressions that I picked specifically because they're special, and we try to figure out how things are related to each other so we can start recognizing them. Okay, if you take a look, 8 and 16, right, how are they related? And some people might say, oh look, if you double 8 you get 16. But if you try some of the other ones, if you double 12 you don't get 36. If you double 20 you don't get 100. So that's not it. Okay? And so we have to find a connection between them. Here's the connection. If you cut this in half, you get 4, okay? And then if you square that, you get 16. If you cut this in half, you get 6. If you square that, you get 36. If you cut this in half, you get 1. Squared is 1. Cut this in half, you get 10. Squared is 20. So really what we're kind of saying is this is B and this is C. We're kind of saying if you take B and you divide it in 2, okay, divide it by 2, and then you get that answer and you square it, that should give you C. Okay? So instead of writing C, I could replace it with this. And so here's the big idea. If numbers are perfect squares, if expressions are perfect squares, they can be written like this. All of the perfect square polynomials can be written in the form x squared plus bx, and then instead of me writing just c, which is usually what goes in that last side, I'm saying, you know what, this is related. If I cut this in half and square that answer, I'll always get that in this last position, the C, what we usually call C. Okay? So this is an important thing because if we're going to use this method called completing the square, our job is going to be to take an expression and say we want to fill in the number so it'll work out for us. So we're going to be looking for that b over 2 squared. This expression here is going to be really important to know, like put a big star there and say this is a really important fact. Okay? Here's the other thing about this fact that's really, really important. In order for this to work out, right up front here, I have 1, right? It's 1x squared. Because we need that 1 to be there to use this nice simple method of factoring, this one-step factoring. So I need that 1 to be there as well. All right, so let's take a look at an example of using completing the square to solve. And so we might start off a little slow. Okay, what we're going to start off with is just completing the square. We're going to start off by making sure that we can turn this into something squared. So the rule said, if you want to fill in the blank here and you want a perfect square to be here, if you take this middle number, okay, 10, you cut it in half and you square that answer. So that's 10 divided by 2 is 5, 5 squared. That you should be able to fill in that value, which for us is 5 squared is 25, and get a perfect square. And if you notice, this is x plus 5 times x plus 5. Right, if we do 5 times 5 and 5 plus 5, which I can write as x plus 5 squared, right? So I use this formula to pick a value so that I would, and I plugged that value in for C so that this worked out and I got this version right here, okay? So let's try the next one. It says negative 30, right? So I'm going to say, okay, this is negative 30. Divide that answer by 2, that's negative 15, and square that, you get 225. So we're claiming that x squared minus 30x plus 225 is a perfect square. And if we check that, it does come out to be x minus 15 squared. And you can check that out, okay? It's possible you might have some decimals and fractions. So for this last one, which it says to try, but we're going to do together, you can do the same thing. We might say, oh, well, 5 doesn't divide nicely. That's a shame. We can't do it. Well, we can still do it. We just won't have really nice numbers to work with. So for this one, I'm going to show you the fraction version and the decimal version, just because we may use both at certain times. So for this one, I'm going to say 5 cut in half, right? Well, 5 over 2 is 5 over 2. It doesn't divide nicely like 30 divided by 2 does. So I'm just going to say 5 over 2 is 5 over 2. And I'm going to square this answer. So this answer squared is 25 over 4. So that means that I can write this as x squared plus 5x plus 25 over 4. And that would be a perfect square. Not really all that nice of a number, but it's correct, okay? If I did the decimal version, when I cut this in half, I would get 2.5 squared, and 2.5 squared is 6.25. So it would be equally as valid to write the decimal version of this. If you go to your calculator and type in 25 divided by 4, you will get 6.25, okay? So both versions get me to an answer, just whether or not we want to use the fraction or decimal version, okay? So we still have some issues that we got to work out, and we haven't done any solving. So let's actually get into. I'm not going to do the b values. Let's skip to actually how to do this. Okay. So if we want to solve using completing the square, here's what we have to do. First thing is, any constant terms that are in the way, we're going to get rid of. So I'm going to leave this up here, and if you want to pause and write down steps, go ahead. But we're going to kind of go through and try this out on a problem, and you'll see what I mean by moving the constant term. So I'm going to look at this problem down here, and I'm going to say, okay, I have this trinomial. A is 1. I got to check that, and we're good here. A is 1. There's a 1 here. That means that I can use completing the square. If it's not, you're going to see we're going to have to fix that. But for right now, we're going to say, you know what? A is 1. Good to go. Okay. First step says, move any constant terms to the right-hand side of the equation away from the variable. So if the variables happen to be on the right-hand side, move them to the left. But we want to get them out of the way. Here's why. If I were to ask you, what should be in this space if I want it to be a perfect square? So kind of like asking you to do these problems. What do I want to be here so I get this nice perfect square situation? We're kind of thinking like, what's my perfect world? What do I want to be there? And so if I were to come off to the side and say, okay, b over 2 squared, well, that looks like 5 squared, 25. Okay, I want there to be a 25 here, and I'm looking at this and saying, you know what? I don't want there to be a negative 12 there. We want there to be a 25 there. So I'm just going to throw 25 or the 12 over to the other side so I have some space. X squared plus 10x, add 12 to the other side equals 0. I'm sorry, equals 12. Let's fix that. Okay, so I got rid of that 12 because I needed the space because I really want there to be a 25 here. Right? So if I'm going to come up to my problem now and say, well, I want to add 25 here. This is my ideal situation. This is a perfect square now. But if I just can't add that, put that in there just because I like it. If I add this in, that's fine, but I just need to make sure that I also add it in to the other side. If I'm going to add something to the left, I need to also add it to the right. So I added it to the left specifically because now this is x plus 5 times x plus 5, right? It's a perfect square. So I'm going to write this as x plus 5 squared. Okay. The right-hand side, I just have to simplify. This is 37. Okay? And so now I can use the square root method. This is a something squared, and so I'm going to say, you know what, let's square root and square root. Okay? And so it depends on how we want to leave our answer. I'm going to leave it in radical form. This says x plus 5 equals, and I'm just going to write this as plus or minus the square root of 37. I don't want to actually tell you that it's like 6.0 something or 6.1 something. I'm just going to leave it in its radical form because it doesn't square root nicely for me, and that's fine. And then what I'm going to do is I'm going to subtract this 5 over, okay, so I'll come up here, and say x equals, well, when I subtract 5 on both sides, this becomes negative 5 on the other side, plus or minus the square root of 37. Okay? So remember, we should get two answers, and this has two answers in it. You're going to do negative 5 plus the square root of 37, which is like 1 point something, and negative 5 minus the square root of 37, which is like negative 11 point something. Right? So we can get two answers out of this, but we want to leave it in its exact form, which means we're not actually going to take the square root. Okay? So let's do one more problem, just so you can get the hang of it. So I'm going to scroll down here. I need to extend my screen a little bit. Okay, so with this one, same idea. I'm going to add the 6 over, get that out of the way. Because if I do a quick check, I'm going to kind of come off to the side here and say 12 or negative 12 over 2 is 6 squared is positive 36. So I would like there to be a positive 36 here. I don't want there to be a negative 6 here. So I'm going to push this to the other side and say x squared minus 12x equals 20. And so if you go back to the top to the rules that I gave you, the first step was move any constant terms to the right-hand side. That's what we just did. We added that 6 over to get it out of the way. Okay, it says divide b by 2 and square it and add this value to both sides of the equation. The left side should now be a perfect square. Let's check. Okay, so we just figured out that I would really like there to be a 36 at the end of this. So I'm going to come up here and say let's add 36. And that means I got to also do that on the right. And let's check, is this a perfect square? Well, this is x minus 6 times x minus 6 works to factor this, which I'm going to write as x minus 6 squared. And this comes out to be 56. Okay, so now I'm going to go to and look at this and say, okay, perfect square, great. Square root it. Square root it. Okay, x minus 6 equals plus or minus the square root of 56. Okay, and if your radical simplifies, you should do that. I don't think this one does. Okay, and so x is equal to 6 plus or minus the square root of 56, and that would be my answer. Okay, so we still have some issues that we got to work out. This method is nice because it's exact and it lets us do all the with any type of problem. Okay, but notice that all of my problems only had a 1 in front of them. I actually specify up here this only works when a is equal to 1. So we still have the issue of, well, what happens if a is 2 or 5 or 10 or something else? And so we're going to talk about that in another video, how to handle problems when a is not equal to 1 using completing the square.